So you guys learned the OR statement. Probability of A or B is equal to the probability of A union B. That guy means OR, right? Which is the probability of A plus the probability of B minus the probability of A and B, the overlap, right? Okay. This is called the general addition rule. General addition rule is when you have the word OR and you are adding probabilities, okay? Then we have what's called the general multiplication rule. Notice the word and the symbol intersect, which means and. And that formula is equal to the probability of A times the probability of B given A. And we can actually derive this from the conditional formula that you guys learned. So do you guys remember the conditional formula? The probability of A and B, not A and B, sorry, the probability of A given B equals what on the top, Sam? Luke, can you help him out? No? No? Anybody remember the conditional formula? There we go. Probability of A and B divided by what? Always the second thing, okay? That's what we learned Friday. That's the given statement. Probability of A given B is equal to the probability of A and B divided by the probability of B. We did all of these when it was both, okay? And we just looked at what was both. But now we're going to start looking at and, meaning multiply. So we can get this formula here by actually dividing by the probability of A right here. Notice this is the given statement right here. So I have that the probability of A and B divided by the probability of A equals the probability of B given A. What's wrong with this formula? If this is the probability of B given A, what should I probably put in the top plus what would I have to divide by if this was in the top? Remember the formula is always divided by the second thing. So if this is the probability of A and B, we divide by the probability of B. All right. So the neat thing about this is you're allowed to switch the order that you multiply in. So I can change this to probability of B and A divided by the probability of A equals the probability of B given A. All right, this formula is on your sheet that you're going to get on the test. This is the formula for conditional probability. So since they don't give you the general multiplication formula, you can again derive it by going the other way and multiplying by the probability of A. And then you can multiply in either order, and you want to put that one first, all right? So you can multiply the two events together, the probability of A times the probability of B given that A happened. Let's try a very simple problem. The Pew Internet and American Life Project reported that 79% of teenagers ages 13 to 17 use social media, and that 39% of teens who use social media feel pressure to post content that will be popular and gets lots of comments or likes. Notice the word and instead of or, all right? Find the probability that a randomly selected teen uses social media and feels pressure to post content that will be popular and get lots of comments or likes. So let's set this up, and I want you to write this down. So we have the probability that they use social media. So I'm going to do an S. And they feel pressure to get a lot of comments. So I'm going to do S and P, social media and pressure. So that's equal to the probability of S and P, just so you know that that symbol means and. And that's equal to the probability that they use social media times the probability that they feel pressure given that they use social media. What's really great about this problem is they just told you both of those numbers right above. So what's the probability that a given teen uses social media? 79%. And what's the probability they feel pressure given that they use social media? 39%. So you didn't have to calculate that given because it says here 39% of teens who use social media feel pressure. So given they use social media, they feel pressure. All right, that's already given to you. And you literally just multiply those together and you get 0.308. About 31% of teens feel pressure to get a lot of comments or likes. All right. Shannon hits the snooze button on her alarm on 60% of school days. If she hits snooze, there's a 70% probability that she makes it to her first class on time. If she doesn't hit snooze and gets up right away, there's a 90% probability she makes it to class on time. Suppose we select a school day at random and record whether Shannon hits the snooze button and whether she arrives in class on time. Make a tree diagram displaying this chance process. So you can make tree diagrams, and they're very helpful anytime you're building off of your first probability. So if your second probability is based off of your first probability. All right, so the first thing we want to do is she either hits snooze or she doesn't. All right, and I want you guys to do this tree diagram with me on your notes. And so we're going to write snooze, and we always box it or no snooze. And they only gave us one of those probabilities. What's the probability she hits snooze? Okay, she hits snooze on 60% of the school days. You put the percent on the arrow. So I'm going to put a 60% right here. They don't give you the other one, but you can figure it out, right? If she doesn't hit snooze, what's that probability going to be? 40. Okay, now the second part is always conditional off of the first part. It says if she hits snooze, there's a 70% probability she makes it on time. So we're going to build from just the snooze, and she's either on time or she's late. And it says if she hits snooze, there's a 70% probability she makes it on time. So I'm going to put a 70% here for my on time. So that means what's the percent that she's going to be late? 30. All right, then they gave us another probability to build off of for the no snooze. If she doesn't hit snooze, so she gets up right away, there's a 90% probability she makes it to class on time. So you don't hit snooze and you're still either on time or late. So she has a 90% chance of being on time. So what percent chance of being late? 10. All right, so that's called a tree diagram. And make note that your second one is always a conditional probability, right? It's based on what happens on the first one. Okay, so you're going to do a lot of tree diagrams tonight, and then you're going to answer a lot of questions based on your tree diagrams. So what is the probability that Shannon hits the snooze button and is late for class on a randomly selected day? So the probability she hits snooze, and, so use your and symbol, is late for class. We're going to use the formula, and we're allowed to multiply them together. So I'm going to do probability of snooze, and I'll just shorten it to S, times the probability of late given snooze. That's always the formula that you're allowed to multiply. And we multiply the probability of she hits snooze. What is that? 60% times the probability that she's late given that she hits snooze. That would be 30%. And multiply those together and you get an 18% chance that she hit snooze and is late. So again, and means multiply. All right. What is the probability that Shannon is late to class on a randomly selected school day? Probability that she's late. Okay. How many pathways are there to late on this tree diagram? Yeah, you can be late by hitting snooze, or you can be late by hitting no snooze. There are two ways, one way or the other way, okay? So you add your two ways of being late together because it's technically an or. She can hit snooze and be late, or she can not hit snooze and be late. One thing happens or the other thing happens, okay? So I'm going to add my two together. So we have the two ways she can be late. Hitting snooze, and she's late. And I'm going to add it to the probability of hitting snooze, and she's not late. Just kidding. I screwed that up. What was the other way of being late, you guys? Not snooze and late. All right. So we multiply each of those together. And I'm not going to write the formula out again for each of these because the formula is you multiply. All right, so the probability of snooze and late is 60% times 30%. You just did that one. That's one way to be late. Okay, and the other way to be late, what are we going to multiply? Okay, 40% times 10%. So this first one is 18%, and the second one, when you multiply, is 0.04. And we add those together, and you get 0.22. So either way, whether she hits snooze or not, she has a 22% chance of being late. Okay? And the final one. Suppose that Shannon is late for class on a randomly chosen school day. What is the probability that she hit the snooze button that morning? Okay, this is a conditional probability. We learned these Friday, and you got to know how to set them up with your given bar in the middle, right? Remember, the first thing is the probability of, and the second thing is what we know happened. That's always how you set up conditional. So the first thing is the probability she hit snooze. So I'm going to do an S. And it says, suppose Shannon is late. We know she is late. That is what we know happened. So you got to set it up like that. And then you have to know your conditional formula, which is on your yellow sheet, but you might as well memorize it. All right. And that formula is the probability of S and L divided by the probability of the second thing, which is L. We just did both of these things, but I'm going to write it out again just to show you what it is we're doing. All right. So in the top is the probability of snooze and late. That means I multiply snooze times late down that one path. All right. So that's 60% times 30% in the top. That's the probability she snoozes and is late. In the bottom is all of the ways that you can be late. That means this times this plus this times this. We did just do that, all right? All of the pathways to late. So she can hit snooze and be late, or she can not hit snooze but still be late. Okay, do you have to show that work? Not necessarily if you just showed it above, but otherwise you would, okay? So I have 0.18 divided by 0.22. This would be fine for work if you just showed it above, which we did, all right? And we get 0.818. So if we know she's late, There's like an 82% chance that she pressed snooze. Okay. So what is a tree diagram? And I would write this down. It shows the sample space of a chance process involving multiple stages. The probability of each outcome is shown on the corresponding branch of the tree, and all probabilities after the first stage are conditional probabilities. Who visits YouTube? All right, video sharing sites led by YouTube are popular destinations on the internet. Let's look only at adult internet users ages 18 and over. About 27% of adult internet users are 18 to 29. Another 45% are 30 to 49, and the remaining 28% are 50 and over. The Pew Internet and American Life Project finds that 70% of internet users aged 18 to 29 have visited a video sharing site. We'll just say YouTube, all right? They visited YouTube. And another 51% of those 30 to 49 have visited YouTube, and 26% of those 50 or older have visited YouTube. Do most internet users visit YouTube and similar sites? So suppose we select an adult internet user at random. Draw a tree diagram to represent this situation. All right, so how many branches do we have on the first one? Kane, how many branches do you think we have on the first one? There are 3. Good. We got to separate it by age group. So I'm going to go 1, 2, 3. So we have our 18 to 29-year-olds. And then we have our 30 to 49-year-olds. And then we have our 50 and overs. And they just tell you basically what percent use the internet. 27% of the adult internet users, or sorry, that was, 27% are 18 to 29. And then it tells us that 45% are 30 to 49. And the remaining people, if they didn't give you this, you just subtract from 100, but they did give it to us and they said it was 28%. Okay, the second thing is conditional based off of the first. So it says that 70% of internet users aged 18 to 29 have visited, we're going to say, YouTube. So we only need 2 branches here. They either visited YouTube or they did not. And it said that 70% of this age have visited YouTube. So what percent have not? 30. Whoa, should have written smaller. Okay, and then we have from our 30 to 49-year-olds, those who have visited YouTube and those who have not. And we go back and see what it says. So it says 51% of those 30 to 49 have visited YouTube. So what percent have not? 49. And then we do our old people. YouTube. No YouTube. Okay, and for our older people, it says 26% have visited YouTube, which means that 74% have not. Okay, so that's first thing, is setting up a tree diagram. Now we answer some questions. B, find the probability that this person has visited a video sharing site. Show your work. So just any random person picked, what's the probability that they have visited, and we will call that YouTube for the video sharing site. So Logan, how many pathways do we have to YouTube on our tree diagram? There are 3 pathways. 1, 2, 3. Okay, you don't have to show all the and statements if you don't want to. You can just tell me what you're going to multiply and what you're going to add. So if I take the first pathway to YouTube through the younger group, Julia, what 2 numbers do I multiply together? Yep. So one pathway is 0.27 times 0.7. And we add it to the next pathway because that's an or statement. They're either going to be 18 to 29 or they're going to be 30 to 49. So Sulav, what's the next 2 numbers I multiply together for my middle group to get to YouTube? Okay, good. So then I do 0.45 times 0.51. And my final way, Cam, to get to YouTube, what do I multiply together? Yep. All right, so multiply and add all those up, and you get 0.49. So just the probability that any random person that you pick uses YouTube is about 49%. All right, part C. Given that this person has visited YouTube, find the probability that he or she is age 18 to 29. So this is a given statement. And I want you guys to try and set it up. So what goes where? Given that they have visited a video sharing site, also known as YouTube, find the probability that he or she is aged 18 to 29. Just that first part would be good. So Cassidy C, what'd you get? Perfect. Okay, order matters, right? So the second thing is what you know, and the first thing is what you're finding the probability of. All right, then we got to know our formula, and you do need to show the formula. So we would do the probability of 18 to 29, and I'll just use a y for YouTube, divided by always the probability of the second thing. And so, Ian, what would I write in the top for the probability of 18 to 29 and YouTube? Not sure. And means multiply. Eve, do you have a guess as what would go on the top? Yeah, so what 2 numbers would I put in there that I'm going to multiply together? Yep. Okay, so 18 to 27 and YouTube, multiply those 2 together. And in the denominator, you guys, we just did that part, the probability of YouTube. So technically, if you didn't just do this, you would have to write out all the pathways to YouTube, right? But we just did that. So let's go ahead and put 0.49 in the bottom. And you would multiply those out and get your answer. My hole punch cut right through that. All right. Okay, last one that we're going to do together. They like to do these false positives, false negatives, and all that. So we got to practice one of these tree diagrams, okay? So many women choose to have annual mammograms to screen for breast cancer after age 40. A mammogram isn't foul-proof. Sometimes the test suggests that a woman has breast cancer when she really doesn't, which is called a false positive. All right, so you got a positive result, but you really don't have it. Other times the test says that a woman doesn't have breast cancer when she actually does. That is called a false negative. So you got a negative test result, but you actually do have breast cancer. All right, suppose that we know the following information about breast cancer and mammograms in a particular region. 1% of the women aged 40 or over in this region have breast cancer. For the women who have breast cancer, the probability of a negative mammogram is 3%. And for the women who don't have breast cancer, the probability of a positive mammogram is 6%. A randomly selected woman aged 40 or over from this region tests positive for breast cancer in a mammogram. Find the probability that she actually has breast cancer. All right. So first we're going to set up our tree diagram. And what do you guys think goes first? Kendra, what do you think? Yep. So I'll just put has, doesn't have. And Aaron, what % of women have breast cancer? Okay, so I'm going to put my 0.01 here. So then, Luke, what goes here? Nope. You either have it or you don't have it. Yes, 99%. All right, now we got to build off of this. All right, you either get a positive test result or you get a negative test result. Even if you have it, you can get a negative test result, okay? That's what this is trying to tell you. So for women who have breast cancer, the probability of a negative mammogram is 3%. So Sam, what goes here? Yes, 0.03. For the people who have it, there's a 3% chance of getting a negative result, which would be wrong, right? And so, Sophia, what's the chance of getting a positive result here? Yep. All right, and then same thing, we got to build from the don't have it. You can still get a positive test result even if you don't have it, or a negative test result. So for the women who don't have breast cancer, the probability of a positive mammogram is 6%. So doesn't have it, positive is 6%. So Allison, what's the probability of a negative? 0.94. All right, now let's set up what they're actually asking. A randomly selected woman over age 40 from this region tests positive. What's the probability she actually has breast cancer? This is a given statement, and you have to be able to recognize those. All right, we're finding the probability she actually has it. Given, we know she got a positive test result. All right, so first plug it into your formula. So it's the probability of H and P. I'll shorten those words over the probability of P. So Addie, what two things do I multiply together that would represent the probability she has it and tests positive? Yep. So you multiply has it times positive. Okay, in the denominator is all the pathways to positive. So Abby, what are the two ways we can get to positive? Yep. Yep. All right, so in the denominator, you're adding both pathways to positive, and you multiply each of those pathways together. Okay, calculate that out, and you get 0.14. What is this actually saying? Given that somebody got a positive test result, there is only a 14% chance she actually has it. Isn't that weird? Doesn't that seem weird? Yeah. That's weird. All right. Anyways, there you go. We're not doing that or that, so